All right, so this is going to be our second day of learning about how to find the volume of a solid. But this time, instead of finding the volume, because we have an area between two curves that we are rotating around an axis of revolution, instead of that, today we're going to have just an area between two curves, and then we're going to be creating perpendicular slices, which right now I understand doesn't make a lot of sense, but it will as we get further on. So this is volumes by perpendicular, and instead of calling them slices, we'll call them cross sections. Volumes by perpendicular cross sections. All right, so if you can remember back to when you first started learning how to find the volume of a 3D figure, we had volumes of rectangular prisms and volumes of cylinders, and those were prisms where they went straight up and down. They had like a circle as a base, and then they went straight up and down, or they had a rectangle as a base and went straight up and down, or a triangle as a base and went straight up and down. And those were the ones where the volume was the most easy to find. The volume was the area of the base times the height. And that is kind of what we're going to be using today, but we're going to be using calculus to do it, which means that our forms are not going to go straight up and down. They're not going to look like a Pringles can. They could definitely like kind of curve and things like that. And so we're going to think of the area of the base as being like a little slice. And then we're going to have another little slice next to it, and another little slice, and another little slice. And we're going to add up all of those slices. And that's how we're going to get the volume. So before we really get started with that, we're going to look at the area that we're talking about. So we're going to have the function y equals the square root of x, and we're going to bound it against the x-axis. That's going to be our second curve. And then we're going to have the interval is going to be from 0 to 4. So let's go ahead and draw a sketch of this to start with. So plug in 0, you get 0. Plug in 1, you get 1. I'm not going to plug in 2 or 3 because those are decimals. But if you plug in 4, you get 2. There's our boundary right there. So this is the area between the two curves that we were talking about. There's our area right there. So what we have now is we're going to say that we're going to find a volume if we use different shapes as cross sections. So if you can picture, this is kind of like the bird's eye view of a loaf of bread. And then on that loaf of bread, we're going to say maybe this is going to be the shape of a square. Maybe we're going to have square slices that are sitting on top of this shape, bird's eye view. Maybe we could have triangle slices. Maybe we could have trapezoid slices. We're going to have all these different shapes of slices. And so we're going to do the area of the base, which maybe it's a square, maybe it's a triangle, whatever, multiplied by the height, which for us is going to be kind of the width because our prism is like laying on its side. All right, so we're going to go ahead and walk through this. I'm going to show you as best I can some like 3D stuff, and then just know if it doesn't make a ton of sense in the video, that's okay, because when we come back, then we'll be able to see it in person and hopefully make a little bit more sense of it. All right, so first we're going to start off with a square cross section. And so the volume is going to be on the integral from 0 to 4. And we're going to do top curve minus bottom curve. So S is going to be the side length of the shape that we're making a cross section of. So that's going to be top minus bottom, just like we did before. And so to build a square, we're going to say that this would be one side of the square, and so that same amount should go up to create the square. So we're going to say side times side is how you're going to make the area of the base. So we're going to have a little square, a little square, a little square, a little square, and then we're going to multiply it by the height. All right, so a square is going to be S squared, and then for us, the S is going to be square root of x minus 0. So we're going to have square root of x minus 0 squared. The side squared dx. Okay, and I'm going to show you what that looks like. So here's my, you can see my shape. There's my bird's eye view. And what I did is I said if I plug in 0.25, then that's 1/4. So then it has a height of 1/2. So this is a length of 1/2. This is a length of 1/2. So there's my first little cross section. That's a square. That's a slice of a square. And then if you plug in 1, that means your square is going to have a side length of 1, a side length of 1. So that's my next one. And I went ahead and I have all these slices. Now, if we were doing this correctly, we wouldn't have any spaces between these slices, but I would have been there forever cutting out paper. So if you can see there, these are your perpendicular cross sections. They're perpendicular because they go straight up and down on the paper, right? They're creating a 90-degree angle. You can see if you look at it, this bird's eye view, we have that square root curve, right? It would touch at 0 and it kind of goes up like this. And if you look at it sideways, there you can see that we're kind of making a prism, right? It's a 3D shape. So it has volume to it, all right? So each of these cross sections are squares, and what we're gonna do is if we think about how that integration would work is we'd be adding this slice to this slice to this slice to this slice to this slice, adding up all those slices, and there would be infinitely many slices. And then when you add all those slices together, that would give you the volume. So that's basically what we're doing. So the shape for a square would be the side length squared. This is the side length squared. And so if we were to integrate that, I'd plug that into my calculator, and I get that the volume is 8 units squared. All right, next we're going to try a rectangle. And we know that the volume of a rectangle is the base times the height. And so when we do these, they're going to have to tell us what the height of the rectangle should be. So the rectangle that I did was one where the height of the rectangle was 3 times the length of the base. So let me show you. This one doesn't stand up quite so pretty as the other one did. So for this one, when the base was 1/2, that means the height of that rectangle is 3/2. When the base was 3/4, then that would be, what is it, 9/4? When the base was 1, the height of the rectangle was 3. So you can see this is going to have a much bigger volume because my slices are much bigger. So again, we're going to kind of set it up. We want to figure out how to write that integral so that we say that the bottom part of the rectangle is top minus bottom curve, and then the height of the rectangle is going to be whatever that was multiplied by 3 because it's base, and then the height is 3 times the base. And then what we're going to do is we're going to use integration to add up each of those slices, and when we're done, it's going to give us the volume of this, which you can see is a lot bigger than what we had last time. But overall, when we do that bird's eye view, we're still seeing that the volume is being formed with that shape of a square root graph right there. So here, I'm going to say that the area of a rectangle is base times height, and the height is going to be 3s. So this is going to be 3s squared. So for our integral, I'm going to say from 0 to 4 of 3s squared, and you can leave the 3 here or you can move it to the front. It doesn't matter how you plug it in the calculator, but we should get a volume of 24, which makes sense, right? Because this was just s squared, so 3s squared would be 3 times that volume. All right, next we're going to go ahead and look at a triangle. So what I have here, and there's different ways you can do the triangles. You could have right triangles. What I did is I created this one using isosceles triangles. So if you look at the triangles, you can see that they have the base is on the bottom, and then the other 2 sides are the same length. And they would have to give you a relationship between the base and the height. So for this isosceles triangle, they would have told us, and they did if you had done this worksheet, they told us in the problem that the height is 1.5 times the base. So if the base was a length of 1, then the height is a length of 1.5. If the base is a length of 2, then the height is a length of 3. So again, we're going to figure out our formula for our triangle. So we know the normal formula for the area of a triangle is 1/2 times base times height. And so here we're going to do 1/2 times s times 1.5 s. Or I guess we could say 3/2. That'd be a little bit easier to multiply. So 1/2 base times height, again, we know that the height is 1.5 s because it was given to us in the problem. So this would be 3/4 s squared. So what I'm doing with this integration is I'm saying, okay, my slices are triangles. I'm going to figure out the area of one triangle. And then if I add all of those triangles up, I'm going to get my whole volume. And you can see right there, that's what your volume would look like. So we can have different shapes for the bases. And then when we multiply by the height, it's going to give us a different volume depending on how big that shape was. So we're going to say the integral from 0 to 4 of 3/4 times root x minus 0 squared. And so that's going to be 3/4 of 8, which is 6. All right, next we're going to go ahead and do a semicircle. So here's my semicircle. Sorry, these were in my binder, so they're flat. Okay. So semicircle is a half circle. Again, we're making all those slices. We can see there's my 3D shape right there that I'm creating. And I'm going to find the volume of. So we have to think about how we could find the area of a semicircle. And so the area of a circle is pi r squared. The area of a semicircle would be 1/2 times pi r squared. So what I have to think about now is how to calculate that radius. So if I look here, if it's a semicircle, that means that the diameter is what is being measured to create this. And so when I have my S, which is the top curve minus the bottom curve, that S represents the diameter. So I'm going to go ahead and write that down on my notes, that the diameter is S, and so the radius is going to be 1/2 S. So I'm going to have 1/2 pi times 1/2 S squared, which is 1/2 pi times 1/4 S squared. So that's 1/8 pi S squared. Okay, so for the volume of the semicircle, we're going to have 0 to 4. Sorry, that's annoying. I don't know if you guys can hear the bell or not. 0 to 4 of pi eighths, I'll call it, because it's 1/8 times pi, S squared dx. And so we've got pi eighths being multiplied by 8. And so this is going to have a volume of pi units squared. Okay, so that was just kind of an example of all the different shapes that we could have for area of the base times the height. And so again, what is creating the height is us adding up multiple of those areas of the base. So this is area of the base. The integral is what's giving us the height, basically, because we're adding repeated shapes. All right, so we could have our shapes being perpendicular to the x-axis. And if you look at this, you can see that that's what I did for all of these, right? They are perpendicular to the x-axis. And so if that's the case, then the S is going to be formed by top minus bottom. Or they can be perpendicular to the y-axis, which means that your S is going to be right minus left. Okay, and then of course, if you're doing top minus bottom, you're in terms of x, and if you're doing right minus left, you're in terms of y. Okay, so that's just something to keep in mind. Now, it will be helpful for us to know some of those general formulas for the different cross sections. So we're going to go ahead and write that as well. We kind of wrote it over here, but we're going to write it in our notes in an organized way so that we can refer to it when we need to. So different cross sections. We have a square, which is going to be s squared. We have the semicircle, and this is the one I would say you need to memorize this one because it's a little bit counterintuitive that it's 1/8 pi s squared. But if you remember where it came from, it's because that the radius is half of the length of s. It's half of the length of top minus bottom because the length of s was the diameter. So this is one I would memorize because a lot of students want to do 1/2 pi s squared and then they get the answer wrong. So semicircle is important. A regular triangle is going to be 1/2 base times height, and so this is going to be 1/2 s times height, and I'm going to leave height in parentheses because the height is going to be something they're going to have to give you information for in the problem. So like the one we did, they said the height was 1.5 times. It's possible that they'll give you a right triangle, which is nice because then you'll know the height is consistent every time or something like that, but just keep that in mind. You're going to have to figure out the height based on the problem. Another one is an equilateral triangle. If you guys recall, an equilateral triangle is one where all three sides are the same length. And this is another one that we would memorize. It's √3/4 s squared. And that's because it's 1/2 times base, and then the height would be √3/2. And that's just something that we know that's a relationship in equilateral triangles. So I'm going to start this. That's one that I would memorize because it's not easy to just make up off the top of your head. A rectangle, we know the formula for the area of a rectangle is base times height. So that's going to be s times whatever they tell you about the relationship between the base and the height. So maybe it's like the example we did where the height is 3 times as tall, so you do 3s, but they could give you another relationship there as well. So that's something you'll have to pay attention to in the problem. So again, if that didn't make a ton of sense to you, that's okay because we will look at it more in class and have lots and lots of examples and we'll be able to see it in 3D some more.